fractions can be easily added when they have common denominators. For example, if we're adding 3/5 plus 1/5, all we need to do is add the numerators when we have common denominators. That is, our answer here is found by adding the numerators for a total of 4/5. Now let's talk about why that is the case. We talked about earlier that the numerator of a fraction tells how many items we have, and the denominator tells how many items compose a whole. So we have 3 items out of 5 that would compose a whole item. Now another way to look at a fraction and the composition of a fraction is like this, that the numerator tells how many, and the denominator tells the size of each of those. So we have 3 items and each of them is a fifth. And here we have 1 item and it is a fifth. So how many total fifths do we have? You see, we have 4/5. Another way to think about it is like this. We have 3 items of this kind plus 1 item of that kind, so we have a total of 4 items of that kind. You see, that's another notion, or another way that we can think about it. And by the way, fractions can be added vertically. For example, here we could think of this as 3/5 plus 1/5. And when we have the common denominators, we just bring together the numerators to give us 4/5. Here's another 2/7 plus 6/7 plus 3/7. Once again, we have the common denominator idea, and so all we have to do is add numerators. And we don't have to put that intermediary step where we have 2 plus 6 plus 3 over that common denominator of 7. That's a safe way to do it. But in the long run, we're not going to write that step. We're just going to say, well, we have common denominators, so to add the fractions, we add their numerators. 2 plus 6, that's 8. 8 plus 3, 11. So this is 11/7. And now we see that we have an improper fraction, so we change it to a mixed number. We say 7 goes into 11 one time with a remainder of 4, so this is 1 4/7. Now, if this division is any more difficult than this, we might want to come out to the side and actually show it as a long division problem. Here's a situation where the denominators are not the same, but we said we can only bring fractions together or add them when we have a common denominator. So we need a common denominator. How do we do that? Well, we are going to change the 2 fractions, but first of all, we need to identify the denominator that these are going to be turned into. Now, how do we do that? Well, it turns out that any multiple of 2 and 3, any common multiple for 2 and 3 will do as a new denominator. For example, 18 is a common multiple for 2 and 3. So I could change these fractions into new ones which have denominators of 18. And remember, the process of doing that is this. 2 into 18 goes 9. 9 times 1 is 9. And in going through that idea, remember, I'm just identifying the number that's to be multiplied in both numerator and denominator to get this. I'm really just multiplying 1/2 by 9 over 9 to get 9 over 18. I'm multiplying by a form of 1 to change the form of the fraction, but not its value. 9/18 has the same value as 1/2. Okay, then here, 3 into 18 goes 6. 6 times 1 is 6. So I have 9/18 plus 6/18. I have a common denominator. I add the fractions by bringing together the numerators. 9 plus 6, 15. 15/18. Oh, but wait, I can reduce this fraction. I see that 3 is a factor in both 15 and 18. So I can say that 3 into 15 goes 5. 3 into 18 goes 6. So this reduces to 5/6. Now, although I said that any common multiple for those 2 denominators will work as a new denominator, as a common denominator, it reduces the amount of work. It simplifies things a little bit if we can identify the least common multiple of these 2 as our common denominator. So it's a least common denominator, you see, that we're really looking for. Now, to identify the least common multiple for a couple of numbers, we can go through the process that we used earlier, thinking about a prime factorization and identifying factors and that kind of thing. That's pretty easy. Another way, though, is to do this. Just take the larger of the two denominators, and it would be 3 in this case, and then think about multiples of 3, and then think about whether or not the 2 goes into those multiples of 3. I'll show you that method a little bit more later, but you're thinking, well, let's see, 3 is the first multiple of 3. Does 2 go into 3? No, not a whole number of times. 3 times 2, 6. Does 2 go into 6? Yes. You see, and 3 goes into 6 because 6 is a multiple of 3. So at any rate, that is a way to do it. Now notice that 6 is the product of these two. And some students tend to think that because the least common denominator often turns out to be the product of two denominators, that we can use that method to find a least common denominator all the time. Well, it does turn out that the product of all of the denominators will be a common denominator. It won't always be the least common denominator, the least common denominator. All right, so 6 now is our least common denominator. So we're going to change our two fractions into new ones which have denominators of 6. And I recommend highly that you put down the denominator that you've identified as the least common denominator and then identify the numerators. So 2 into 6, 3. 3 times 1, 3. Then 3 into 6, 2. 2 times 1, 2. And now that we have common denominators, we add the fractions by adding the numerators. 3 plus 2, 5. So 5, 6, as we found before. Let's add these fractions vertically. Now notice that the fractions have denominators that are not alike. The first thing we need to do is to change into new fractions, equivalent ones, having a common denominator. Now notice with 4, 5, and 8. 8 is the largest of these. And the way that you go about finding the common denominator, the least common denominator, is like this. You want the least common multiple of 8, 5, and 4. And because you want the least common multiple, here's what you might do. You might think, well, I'm going to think about it this way. And right over here is a thought bubble. This is the way we're thinking about it. The largest of the denominators is 8. So we're going to think about multiples of 8. All right, so we have, let's see, we have 8, then we have 16, 8 times 2, then 8 times 3, 24. You see, and every time we write one of these down in our head, we think about whether or not the other two numbers will go into it. You see, so for the first one, we would say, does 4 go into 8? Well, yes. Now, and this might be it. Does 5 go into 8? No, we have to discount that one. Okay, then 16. Does 4 go into 16? Yes. Does 5 go into 16 a whole number of times? No, we have to discount that. So then the next one, 24. Does 4 go in? Gee, you know, 4 is going to go into all of these multiples of 8 because 4 will divide every multiple of 8 because 4 is a factor within 8. So we don't even have to worry about 4. It'll be taken care of. It's the 5 that we're concerned about. So let's see. Let's just think then about the 5. Does 5 go into 24 a whole number of times? No. What's the next multiple of 8? This was 8 times 3. 8 times 4 is 32. Does 5 go into 32? No. Not a whole number of times. 8 times 5, 40. Ah, here we go. There's the one. Bingo. So now our least common multiple and therefore least common denominator for these three fractions is 40. So we're going to change these into new fractions which have denominators of 40. And again, I recommend highly that you write that denominator and then identify the numerator. Don't do it all on the fly. All right, 4 into 40 goes 10. 10 times 3, 30. Then here, 5 into 40 goes 8. 8 times 4, 32. 8 into 40 goes 5. 5 times 5, 25. Now that we have new fractions with a common denominator, we bring the fractions together. We add them by adding numerators. So we're adding 30 and 32 and 25. The numbers are big enough to where I can't see through this, and therefore I'm going to look at digits. I'm going to look at the ones digit. 0 and 2 is 2 and 5, 7. 3 and 3, 6 and 2, 8. So 87 over 40. An improper fraction. I'd like to change to a mixed number. So to do that, well, let's see. Can we see through the division of 40 into 87? Go like this. Maybe not, you see. So we'll come out to the side and we'll say 40 into 87. 40 into 87 goes 2 times. 2 times 0, 0. 2 times 4, 8. Subtract, we get 7. The remainder is 7. We put the remainder over the divisor. And this then becomes 2 and 7/40. All right. Let's talk about, let's introduce the notion of adding the fractions with whole numbers or adding mixed numbers with one another and that kind of thing. There are two situations that are relatively trivial. One of them is this, where we have 2, a whole number, plus a fraction. And that's really easy. There are two ways to look at it, though. One way is kind of complicated, and the other way is really, really easy. I'll show you the complicated way first. The complicated way is to say, well, let's see. We have a denominator of 5, so our common denominator is 5, so we're going to change both of these into new fractions whose denominator is 5. And we're thinking of 2 as 2 over understood 1. So we think 1 into 5 goes 5. 5 times 2 is 10, so 2 is really 10/5. And 5 into 5 goes 1. 1 times 4 is 4. This is just 4/5. So 10/5 plus 4/5 is 10 and 4, 14/5. And changing into a mixed number, 5 into 14 goes 2 with 4 left over. So 2 and 4/5. 2 and 4/5. 2 and 4/5. That's what we had to begin with. You see, when we're bringing together a whole number and a fraction, we just need to write them next to one another. 2 and 4/5 means 2 plus 4/5. So 2 plus 4/5 means the same thing as 2 and 4/5 written like this. Just bring them together. You see, in a mixed number, you have a whole numbered part and a fraction part. So you just write them next to one another without the plus sign. All right, so that's really a trivial situation. This is trivial as well. When you have a whole number and you're adding a mixed number, then all you do is just add the whole numbered parts and add the fractions. Now, the fraction here is understood to be no halves. You see, so we have 5 plus 3. So the sum of the whole numbers is 8, and no halves plus 1/2 is 1/2. So add whole numbers to whole numbers and fractions to fractions in this kind of circumstance. And that kind of prevails when we're adding mixed numbers as well. Here we're adding 2 and 7/9 plus 3 and 5/12. So we're going to add whole numbers to whole numbers and fractions to fractions. Now, a handy way to write problems like this, to find the common denominator and so forth, is to set it up vertically. And it doesn't matter so very much. You can do it either way, but this is real handy because we can kind of work out to the side to find the common denominator. So here's what's happening. Now, we need common denominators in order to bring these together. So we're going to come out to the side and write new fractions with a common denominator. Common denominator is the least common multiple. We want the least common denominator that we can find. Now, when you come out to the side, there is a tendency, because we're finding common denominators for just the fractions, the tendency is to just bring fractions over to the side. But we don't want to do that. We want to bring the whole numbered parts over as well. So we're going to have 2 and the fraction and then 3 and the fraction. We want to maintain the integrity of these equal signs. What's over here needs to have the same value as what's over here, you see. All right, so that's the idea. Now, remember the thought bubble idea for identifying least common denominator or least common multiple between 9 and 12. Here's what you're thinking. You're thinking, okay, multiples of 12. Does 9 go into 12? No. 24. Does 9 go into 24? No. 12 times 3, 36. Does 9 go into 36? Yes. Bling, bing, bing, bing. Okay, so 36 then is the least common multiple, and therefore the common denominator, the least common denominator for these two denominators. So we're going to write a 36 in these denominators. And away we go. 12 into 36 goes 3. 3 times 5, 15. And 9 into 36 goes 4. 4 times 7, 28. Now we can add. Now remember, it's whole numbers and whole numbers, fractions and fractions. 2 and 3, 5 for the whole numbered part. 28 and 15. Well, let's see. 8 and 5, 13. Carry 1. 1 and 2, 3, and 1, 4. So 43 over 36. Whoa, we have a whole numbered part and an improper fraction part. And the way we're thinking about this, in order to resolve this, we're thinking, well, this is really 5 plus 43 over 36. And I'm going to change 43 over 36 into a mixed number. Now, if we're anywhere near confused about that, then come to the side somewhere and divide 36 into 43. You might be able to see through it, and that's just fine. But if you can't, come to the side and do this little operation. And don't be ashamed of doing this. It is part of your problem, and it should be demonstrated, or it should be shown just as eloquently as every other part of the problem that you show. 36 into 43 goes one time. 1 times 36 is 36. When we draw the line to subtract, let's see. 6 from 3 won't go. Borrow from the 4, it becomes a 3. The one that we borrow makes this 13. 13 minus 6 is 7. So the remainder here is 7. So this is 1 and 7 over 36. So we march back over here. 1, this part is 1 and 7 over 36. Now we bring these two together by just adding the whole numbered parts. We have 6 then and 7 over 36 for the answer. Let's do another one. This one involves 3 mixed numbers, and once again, I think a good approach on problems like this is to arrange them vertically. Now, I do want you to know, though, that they can be arranged horizontally like this. We would bring down the 5, the 11, and the 12, and we would identify, oh, let's do it that way. We would bring down the 5, the 11, and the 12, and we're leaving a place for a new denominator in each one. You see, we want a common denominator for all of these. And it's the least common denominator we're looking for, or the least common multiple among these. And it's fairly easy to see. The largest one is 9, so think about multiples of 9. 9 times 2 is 18. 3 goes into 18, 6 goes into 18, and obviously 9 goes into 18. So 18 is our least common multiple or least common denominator. Now we change the fractions into new ones like that have that denominator. So 3 into 18 goes 6, 6 times 2, 12. 6 into 18 goes 3, 3 times 5, 15. 9 into 18, 2, 2 times 7, 14. Now, this is what is troublesome using this horizontal method like this. This is why the vertical method is sometimes a little easier. It's because when you line things up vertically, you can kind of see digit value a little bit easier. And here we have to be very careful about digit value. When we add the 5, the 11, and the 12, for example, it's 5 plus 1, 6, and 2, 8. For the ones digit, and then for the tens digit, we have 0 here for the tens digit, and then 1, and then 1. So it's 28, you see. Now another way to get the 28 is 5 and 11 is 16, 16 and 12 is 28. Whatever's comfortable for you. But if you had arranged vertically, it would be a little bit easier to see the 28. And I think it's a little easier, too, to see the sum of the 12, 15, and 14 as well. Bringing those together, let's see, we would have 2 and 5, 7, and 4, 11. Write the 1 and carry 1. 1 and 1, 2, and 1, 3, and 1, 4. So 41 over the common denominator, 18. Well, can we see that how many times 18 goes into 41? I can't. So let's go over to the side. So we would have 18 into 41, and it goes twice. 2 times 8, 16, carry 1. 2 times 1, 2, and 1, 3. 1 minus 6 won't go. Borrow from the 4, it becomes a 3. The one that we borrow makes this 11. 11 minus 6, 5. So we have 2 with 5 as the remainder. Put the remainder over the divisor. And this becomes, this part of it becomes 2 and 5/18. So what we have here is 28 plus 2 and 5/18. 28 and 2, 30. So this is 30 and 5/18 for our final answer. Take a look at this word problem. It says, a rain gauge collected 3 1/3 inches of rain in October, 5 1/2 inches in November, and 3 3/8 inches in December. Find the total rainfall for the 3 months. Now, a lot of times you can recognize that the operation to be performed, as in this case, is addition, but just be careful about the numbers you're adding. And make sure you're adding the numbers you're supposed to add to get the result intended. For example, it would be a careless mistake to think that we're not only adding these 3 numbers, but we're also adding the 3, you see, in this. But this is 3 months. It's not some amount of rainfall. And we're just adding the rainfall in the 3 months, and that would be these 3 mixed numbers. So we take these 3 mixed numbers and we add them. Notice that we need a common denominator. The common denominator here, the least common multiple for the 3 numbers, turns out to be 24. So we come out to the side and we write 2 and some number of 24ths. We write 5 and some number of 24ths. We write 3 and some number of 24ths. And now we identify the numerators. 3 into 24 goes 8. 8 times 1, 8. 2 into 24, 12. 12 times 1, 12. 8 into 24, 3. 3 times 3, 9. And now we're ready to add. For the whole numbered parts, let's see, 2 and 5, 7. 7 and 3, 10. And for the fractions, 8 and 12 and 9 is what we're adding. 8 and 12, that would be 20, and 9, 29. So this is 29 over 24. And now we have an improper fraction part in our mixed number, so we think of it as 10 plus, and 24 into 29 goes 1 time with 5 left over. So this is 1 and 5/24. We add the whole numbered parts here to find 11 and 5/24, and we would write our answer probably as a complete sentence. The total rainfall for the 3 months is 11 and 5/24 inches of rain.